And again, this is for the Field Methods and Technology course. So module 6, this is actually going to be your last lab, because then the next couple of weeks is going to be focusing on a few discussions and getting your final paper ready. So with that, let's go ahead and I'm going to share screen to module 6. That way we are all on the same page as to what is due. All right, so you should see my screen here for module 6. And module 6 is really going to look at climate change and how scientists are monitoring global temperature, looking at increases, variability, and looking at some of these things that can contribute to this. So with that, let's go ahead into the introduction here. So the module 6 introduction. So again, just to kind of get familiar with what we'll be doing here. So our learning objective course is looking at different methods, looking at techniques, environmental factors that can influence or impact global climate change, and looking at very specific things called feedback loops. You'll have a discussion about that, which we'll get to in a second here, and how those kind of come into play as well. So that is the overview. What to do for this week. So under the resources, under climate change, be sure to read this lab manual here. And it's called Greenhouse Gas and Sea Level Rise Manual. So here you'll look at carbon emissions and how those have been linked to climate change, their influence on sea ice and glacial melt. Also looking at how climate works, the impacts of climate change, our human health impacts of climate change, some of the indices or indicators here in terms of ecosystems, and a video looking at why does climate change matter. So a video with a NASA scientist. There's also some more supplemental information here looking at NOAA, and again, looking at sea level rise and looking at the World Climate Simulator as well. So lots of great information there about climate change. Your discussion this week is going to look at what we call feedback loops. So climate feedback loops are very important when we study climate change because really it can increase, which is a positive, or decrease, which is a negative in terms of warming effects. So what you're going to do in your initial post, you're going to select an example of a feedback loop, and you're going to describe the feedback loop in particular. You're also going to say whether this is positive or negative. So for instance, you might want to look at water evaporation and cloud formation. Maybe you want to look at the interactions between plants and soil. Some of you have done the life science class with me. So we talked a lot about plants and soil and their interactions together. Maybe you want to look at permafrost melting and methane being released. So again, different examples here. So these are some examples that are listed for you. If you Google them, there's a ton of other examples that you can look at. Also just looking at ocean absorption in terms of carbon dioxide as well. So again, you're going to, in your initial post that's due by Thursday, you're going to discuss what your feedback loop is, what it is, explain it to us, and then let us know if it's positive or negative and why. Then in your responses to your classmates, you're going to choose a different feedback loop and talk about how this can disrupt or impact an ecosystem and ways that scientists can collect data, because again, we're looking at field methods and techniques here, so how that data collection can really help determine the effect of the feedback loop. Your other assignment due is going to be your lab. So this is your last lab here. So you might be able to see this one here. Again, my screen might pop in or out. So anyway, it's called Climate Change and Sea Level Rise. It has like a little kind of a lunchbox, kind of a plastic little thing. There's also a what they call the Bogan Universal Indicator, like a kind of a rainbow colored scale here, a little pH scale, and some blocks and cups in here. So make sure you have the correct one here. I'm going to stop sharing this one. Let me share the lab report here, because this is very important. Be sure to be very careful with this lab because your preparation is going to take 24 hours. So do not begin this lab, of course, on Sunday because you're going to be late. The activity 1, you're going to be building a model from a contour map. That's going to take about 2 hours. Your second activity is going to look at sea ice and sea level rise. That's another hour. Your third activity is going to be on glacial ice and sea level rise, another 2.5 hours. Ocean acidification is 30 minutes, and activity 5, improving the model, which can be optional, is another 45 minutes. So in addition to the full day of prep, you're looking at 2, 3, 4, 5, 6, almost 7 hours of lab. So be sure to make sure you really look at your time here. So again, just kind of follow the directions here about the background. Again, there's all the materials that you need, the plastic container, the ruler, some additional info or some additional materials you'll need, not to, you know, these are typical household things that you should have. And then begin with the lab experiment and recording your data. And then the last thing I wanted to kind of bring about back to the Module 6 window here is your final paper. So your final paper, there's a little reminder here, it's not due until Module 7 next week, but can't hurt to put everything together and get started on condensing your final paper here, okay? So again, we're doing climate change for Module 6. So you have your discussion about the feedback loops, your initial discussion due on Thursday, your 2 follow-up responses due on Sunday, and then your climate, your greenhouse gas and sea level rise lab, making sure that you begin that at least, I would say, by Thursday, Friday at the latest, just to give yourself some wiggle room there. That lab also due by Sunday. Let me know if you have any questions, and I look forward to some great discussions online this week.